Now we go on to prove the third result, that is all altitudes of a triangle are concurrent. Now we are aware that an altitude means it's a segment drawn perpendicular from any vertex of a triangle on the opposite side. Okay, so here in triangle ABC we have shown the three altitudes AD, BE and CA, and we have to prove that they are concurrent, that is they pass through a single point. Now the method to prove this is slightly different than the previous results of proving the concurrency of medians and angle bisectors, because in those cases we had an advantage of knowing some ratio of some internal division somewhere, right? But here we don't have such information available with us. So here what we are going to prove is, we are going to consider only two altitudes first, okay, and we name their point of intersection as say P, okay. And what we now prove is, if we join segment CP, that is if we join that intersection point with the third vertex on extending, it must be perpendicular to the opposite side AB. So that means if we show that CP is perpendicular to AB, in that case it would mean that the segment CP extended itself is the altitude, right? So that would prove that the third altitude also passes through the same point P, right? So this is the general scheme that we are going to follow to prove this particular result. Alright, so let us first of all name the point of intersection of AD and BE. Okay, so for now we are going to consider and concentrate only on the altitudes AD and BE in the figure. So we can definitely write that the segment AP is perpendicular to BC, correct? Because this particular segment AP is perpendicular to BC. And similarly we can write BP is perpendicular to AC. Now if two vectors are perpendicular, then clearly we can say that their dot product has to be 0. So therefore we write the two dot products. Okay. Continuing further, we can write the actual expansion. So AP bar can be written as P bar minus A bar dot BC bar is C bar minus B bar is equal to 0, and for the second case we have P bar minus B bar into C bar minus A bar is equal to 0. So we go on to expand these. So therefore simplifying the first one, we will get P bar dot C bar minus P bar dot B bar minus A bar dot C bar plus A bar dot B bar is equal to 0, and simplifying the second one, we have P bar dot C bar minus B bar dot C bar minus B bar dot C bar plus B bar dot A bar is equal to 0. Now if we subtract the two equations, that is from the upper equation we subtract the lower equation, so the term P dot C will get cancelled as well as A dot B will get cancelled. A dot B same as B dot A because it is commutative. So what remains is C minus P dot A. I think there is some mistake here. The first term should have been P dot C, then minus P dot A, right? There is a little mistake here. P dot A, then the next term is minus B dot C plus B dot A, correct? Alright, so that's fine now. So here the second term will become positive, so P dot A, this term becomes positive because it is getting subtracted, minus P dot B. Similarly the next one, that is B dot C, gets positive, minus A dot C is equal to 0. Right? So from the first term we can take P bar common and dot into bracket A bar minus B bar plus from the second term we can take c bar common, dot into bracket b bar minus a bar is equal to 0. Now in the second term we just change the order. So instead of b bar minus a bar, we want to have a bar minus b bar so that it can be taken common in the next step. But if we do that, we have to make the c bar as negative is equal to 0. So therefore taking common, we have a bar minus b bar dot p bar minus c bar is equal to 0. Therefore that means a bar minus b bar is nothing but ba bar dot p bar minus c bar is cp bar is equal to 0. So that means look at the figure now once again what we have got. BA stands for the side BA and CP stands for the segment joining the point of intersection of the first two altitudes that we saw earlier and the third vertex. So now if from the figure it's clear that if BA and CP have their dot product as 0, that means BA must be perpendicular to CP. And if BA is perpendicular to CP, that means BA must also be perpendicular to CF because CP and CF are on the same line. So what we have shown is through the point of intersection of the two altitudes, okay, if we join the third vertex, then that also gives us the altitude of the triangle, which is the third altitude. That means the third altitude also passes through the same point of intersection of the first two altitudes. So therefore all altitudes of a triangle are concurrent, and the point of concurrency is called as orthocenter and typically denoted as capital H.